So integration by parts is another technique that we have for integration. Things that were previously impossible, we're now going to be able to do. It actually comes from the derivative of a product. So we have derivative of u times v is the first times the derivative of the second, u dv, plus the second times the derivative of the first, v du. If we subtract v du to the other side, we can solve for u dv. So I'm going to rewrite it as u dv equals derivative of uv minus v du. If we integrate all three of these, then we get the integral of u dv equals uv minus the integral of v du. This is the formula for integration by parts. So we're going to take something, then we're going to split it up and find the integral. So we have the integral x cosine x dx here. We're going to let u equal x and dv equal cosine x dx. So all I did was I took the first part here and the second part here. We need to make sure we watch where the dx goes because we got to make sure we take care of that. And what we're going to do is we're going to integrate this left side, or take the derivative of the left side and integrate the right side. So we're going to get du equals dx. That's an easy derivative. And then integrate this, v equals sine x. When we write our next line, we're going to do u times v and then multiply across the integral of v du. So we have the integral of x cosine x dx is equal to x sine x, that's u times v, minus the integral of, now we're going to have v times du, sine x dx. So we integrate that, we're going to get x sine x plus cosine x plus c. So it's not pretty, but we can do it. And remember, we can't always do it. We had choices when we did, when we were choosing our u and our dv. So I laid out several of those. If we just said u is 1 and dv is the whole thing, well, that's what we started with. We'd get the integral of this, and that doesn't help us. This is the one we did, so that's up there. If we do this after the first, applying the integration by parts, we would get x squared cosine x minus the integral of x times negative x sine x plus cosine x dx, which is way more complicated than what we started with. Over here, we would get 1/2 the integral of x squared sine x dx. And again, that's something I don't think we can actually do without applying integration by parts. You will find, the more you do of these, you will find an instinct for what to use as your u and your dv. So here's that first integral that I said that we could not do yet. We can do it now with integration by parts. It's got to be our derivative part, though, remember, because we don't know the integral of natural log of x. That's what we're trying to find. So u equals ln x, dv equals dx. Take the derivative, we get du equals 1 over x dx. Integrate here, v equals x. So we'll cross multiply u and v and multiply across on the bottom. And we get x ln x minus the integral 1 over x times x dx. Well, that's x natural log of x minus the integral of 1 dx. So x, the natural log of x minus x plus c. So the integral of natural log of x is x, natural log of x minus x plus c. Now we can do it. Let's look at this next example. Like I said, the more examples we see, the more we'll feel comfortable picking our u's and our dv's. So we'll start. We're going to say that u is x squared, dv is e to the x dx, because those are both things that we can do. The derivative here is du equals 2x dx. Integral here is v equals e to the x. Can handle both of those. So uv is x squared e to the x. We're going to subtract the integral of this product. I'm going to put the 2 out front because it's just a constant. And we get x e to the x dx. Well, I don't recognize this yet, but we could do the integration by parts technique again on this. So let's do that. Let's say u equals x and dv equals e to the x dx. Derivative would be du equals dx. Integral would be v equals e to the x. Again, we're going to cross and then multiply there. So we have x squared e to the x minus 2 times, and now we're doing the integration by parts again. X times e to the x minus the integral of e to the x dx. So I'm going to distribute a negative 2 as I go along here, simplifying. We have x squared e to the x minus 2x e to the x plus 2. Now the integral of e to the x is e to the x, and we get a plus c at the very end. Now, what we just saw here is something where we can use what is called the table method. And the table method works in 2 special cases. One, when we have something that decays and is going to eventually, as you take derivatives, is going to go away. So some kind of polynomial. Or something that repeats, like a trig function. So let's start with this polynomial. And here's how the table method works. We're going to pick one side to be the derivative and one side to be the integral. You always want the thing that's going to disappear or decay to be your derivative. So that's going to be your x squared. And we're just going to go until it disappears. So x squared, derivative of that is 2x, derivative of that is 2, derivative of 2 is 0. Integral, the integral part was e to the x. We're going to integrate that. That's e to the x. Integrate that, e to the x. Integrate that, get e to the x. Now here, so derivatives, integrals, we've got that. We start with a plus, and then alternate signs. Plus, minus. And then we're going to pair things at an angle. So we're going to go this way, this way, this way. And then anything times 0 is 0, so it's gone. So we start here, and we don't have to write the plus sign because that'd be weird. We have x squared e to the x. Move down, minus 2x e to the x. And then plus 2 e to the x. And then we get a plus c at the end. If you look, they are both the same answer. So that's kind of fun to do it that quickly. Let's look what happens when you have a trig function. Okay, so we'll have our derivative and our integral. Our derivative will be our polynomial. Our integral will be our trig function. Derivative of this would be 3x squared, 6x, 6, and then 0. We can go and do our plus and minus. Plus sign, minus sign, plus sign, minus sign, plus sign. Derivative of sine is negative cosine. Derivative of negative cosine is negative sine. Derivative of negative sine is positive cosine. Derivative of cosine is sine. Sorry, I should have been saying integral. Integral of sine is negative cosine. That's why this was all backwards to me. I knew the signs because I've done this recently. integral of negative cosine is negative sine, integral of negative sine is cosine, integral of cosine is sine. Sorry about that. I was just saying it backwards. We're going to, again, connect these through the diagonals there. We'll start with x cubed. There's a minus sign, so minus x cubed cosine x plus, because of minus minus, 3x squared sine x plus 6x cosine x minus 6 sine x plus c. Way better than trying to do integration by parts multiple times in the normal fashion. Okay, let's try another one. This time we don't have anything that's going to, when we take the derivative, it's not going to decay and disappear. It's just going to, e to the x repeats itself, cosine has its own pattern. So we're actually not going to use the table method here. Nothing really fits. But let's start. Let's just try. Let's say u equals e to the x, dv equals cosine x dx. Integrate, that's easy, or derivative, that's easy. Integrate, we get v equals sine x. Product, and integrate that product. So we get e to the x sine x minus the integral of e to the x sine x dx. We're not quite there, but let's do it again. Let's just see what happens here. Gonna keep going. I like this division still. The derivative here is e to the x dx. The integral here is negative cosine x. So this drops down and we have e to the x sine x minus, now we're doing cross and across, so negative e to the x cosine x plus, because it would have been minus negative, integral e to the x cosine x dx. Well, this is what we had up top. So if we put these, this is supposed to be equal, so integral e to the x cosine x equals e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. Well, let's add this to the other side and we get two of them. 2 integral e to the x cosine x dx equals e to the x sine x plus e to the x cosine x. Divide by 2 and we'd have it, right? Integral of e to the x cosine x dx equals 1/2 times e to the x sine x plus e to the x cosine x plus c. Which is pretty amazing. But again, that's going to happen sometimes when you've got that trig function that's going to alternate signs and it's got its own pattern. You may end up with the same thing that you start with and be able to do something like this. So keep an eye out for that.